So good morning from Las Vegas. The temperature is 41 Celsius, 106 Fahrenheit, and we are going up from here because it's just 10:30 in the morning. Um, Full disclosure, I'm not a cybersecurity person. I am a system person, automotive system person, but I was asked to give a little bit like an external view into this. So what are the risks to software-defined vehicles? Let me give you a quick introduction where I came from. I'm in the automotive industry for about 20 years. As you can see, went through several large companies. The most important or interesting for this talk is probably I spent 6 years at Tesla, from the very first Model S in 2012 all the way to the mass production of Model 3 in 2018. I was responsible for the team for the vehicle software validation. So the entire vehicle software went through my team and my signature. I signed off over 750 releases in that time. We averaged 150 software releases to the end customer per year. That translates to about 3 per week. We ran 2-week agile sprints. So every agile sprint has a release every 2 weeks. And then every release has about roughly 5 hot fixes. That's where the number comes from. Afterwards, I spent a year at NEO as a director for integration of smart components, so Linux-based components. And starting 2019, I joined iProcess Consulting, bridging the gap between the classic automotive industry and the Silicon Valley style companies and their processes and strategies. All right, let's jump right in. So cars were invented about 140 years ago, and they have been a mechanical product for probably the first 80 of those years. Starting in the 1960s, they started to become more electric things in those cars, but they're still a pure mechanical product. Until we reached the 1980s, and in the 1980s, the electronic control units started to go into the vehicles, which was, funny enough, also the time when the CAN bus emerged. So this is how old the CAN bus is. And so for about 40 years, we had the second generation cars, the EE, or electronics and electric architecture vehicle. And we have seen that basically all the way up to the 2020s. But now we're talking about software-defined vehicles. And the term software-defined vehicle, you see, like if you ask 10 people, you probably get 12 answers what that means. And basically, in my way, the simple term is it's like a decoupling of hardware and software. So the features of the car are decided by the software, supported by the hardware, and the software is not specifically made for this very one car or platform. So I'm sure most of people heard about that. It's just to warm you all up. So why do we do that? So of course, engineers, they always go cutting edge and they do something because they can, but there's also really good reasons why we do software-defined vehicles. One of them, you have a continuous improvement of the user experience. What I found here is some pictures. So you see a Tesla Model S from 2013, the navigation screen of my friend Christoph driving through the Bay Area. And you see how old that is, because on the top there it shows 3G for the internet connection. And then on the right side, you see a rather modern screenshot. So this can be the very same car. Obviously, the 3G doesn't magically change to 5G without a hardware change, but the rest, what you see there is a pure software-defined vehicle improvement. So the customers are getting a product that stays up to date and fresh continuously. People are getting used to that from these devices. And actually, they are starting to expect things like this coming also from their cars. I always hit my keyboard, but that doesn't change the slides. Customer interaction after initial sale. So this is something brand new. So far, car makers, they built a car, they gave it to the dealers, and the dealers sold it to the end customer, and the car maker had nothing to do with these cars anymore. The cars came back to the dealership for service or repairs, but the OEM was actually out of the picture. Now, with a software-defined vehicle, you can actually start having OEMs interacting with the customers after an initial sale, which is great. So maybe you buy a car and you don't have a budget, or you don't know that a certain feature is available or you want it. Later down the road, you can actually add that feature, and you pay the OEM a fee for that, and you have a feature that you did not originally purchase. The other thing is, secondhand car market. That's a beautiful idea. Now suddenly, if I want to buy a car, I don't have to make sure to buy the car with all those features exactly the way it is already right now, because I can just buy the car in the color and design I like, and I can add the features afterwards. And so the OEM can also start to monetize the aftermarket and the secondhand market, or third even. Click. Also, complete new ideas of revenue streams. You can actually start renting out features. So the software-defined vehicle allows you to activate and deactivate features remotely or temporarily. Imagine you don't want to pay for example, here for the full self-driving capability, but for your long vacation trip, you would like to add that just for a couple of weeks or for a month. So you pay a fee for a month and then it's getting removed. Obviously, the OEM hopes that you're continuously subscribing, but you as a user have the option to sign in and sign off on certain features. Here's something very important for the OEMs now. So you have a complete feedback loop. So you can get a feedback either, as you see there on the left, a direct feedback. So I don't know if everybody's aware, but in a Tesla, if you hit the voice button and you say bug report, you can send a voice message directly to the Palo Alto headquarters. I was part of the team receiving those for a while. And then you get actually a direct feedback loop. But you also have all the data coming from the car, and you can actually look into how the car is really used and how the user actually uses the performance of the functionalities and the longevity and so on. So far, car makers are building cars and they never hear back how over-designed they had their cars. They only know if they're under-designed, because you get cars that break and they come back to service, so you get return parts. But if you over-design by factor 100, you will never hear about that, because you never know actually how the car performs in the field. Preventive maintenance, very, very important topic. So it's, I don't know if you can see that on the right side picture, but if you have a 12-volt battery that needs replaced over the next couple of weeks, you get a message, you call service, they change that, you don't have a breakdown of your car. It's a gigantic improvement, both in cost, because I read somewhere that a broken down car on the highway costs at least 10 times as much to fix than a car that comes in for service before it breaks down. And then the second is also the user experience, and the brand management is much better here, because you don't have a disappointment that you have actually a breakdown event. And you avoid the physical recalls. So physical recalls can be replaced in a lot of cases by a software update over the air. So you don't have to bring the customers back. They don't have to take a rental car for a day. They don't have to have this disappointing event at a service center and so on. It can just happen overnight in their garages. So same thing. So it costs a lot of cost saving, but also a lot of reputation improvements. Okay, so this was just the summary why the software-defined vehicle is actually happening, and what are the opportunities and what we are going to see in the years coming from now. So what are the implications on security? So as we just heard from Agnia in the talk before, connectivity is essential for SDVs, for electric cars in general as well, but for SDVs that sit on top of electric vehicles. And connected vehicles are automatically a target for malicious attacks. We haven't seen too many of those yet, because they're becoming more and more prevalent in the market. So I'm sure we will see more action there. But anything that's connected and actually can be utilized in a bad way is a target for a malicious attack. So vehicles can become an entry point into other systems, but it's also important to understand that other systems can become an entry point into the vehicles as well. And this is what makes connected vehicles so vulnerable, because it's one thing to attack one car, like what we saw with the G-Pack a long time ago, or your car charging in the garage and suddenly discharging not charging overnight or discharging into the grid or something. But once you have a connected fleet, you actually start to see swarm attacks, and that's making it much more harmful. And then, as we heard earlier from Dan already, the UNECE R155 compliance is now required for type approval in the European Union. And that, for people, for folks here who don't see that, the scale of that. So Porsche just had to ditch two of their most successful cars June 30 this year, the Macan and the Boxster, because they are not compliant with the UNECE R155. So it's a gigantic impact. and they decided to actually take them out of production rather than retrofit them with a cybersecurity management system. Okay. So I want to talk about V2X today. So V2X, as we heard briefly in the opener from Dan, vehicle to everything communication. So that means there's a vehicle to user, to other vehicles, to your home, to your grid, to infrastructure. And I want to talk about each of those and see what kind of vulnerabilities and threats are actually around each of those connectivity areas. So, wow, that got messed up in the formatting. That's why I usually like to share my own screen rather than sharing that. Hi, Christine, can you jump in here real quick? Could I just change and share my screen here, please?
Sure, I think that I can just pull this down. Let me just try. There you go. Now let's see if you can just share your screen.
One second. Sorry, everyone, for that, but
all good.
That
it happens to me too. I know it drives me crazy when that happens to me.
Okay, so let me just share my screen and share. Could you confirm if that works? Because
let me just try.
Yeah.
It works. Let's just make sure that's the right one. Yes, perfect. Okay.
Perfect. All right, so we're back on. Here we have the two Porsches again. We have this picture. Okay, so threat opportunities to V2U, so vehicle to user. So you have the opportunity or the threat of remote hijacking. We talked about that before. I will not go into detail about that, but we heard about that before in other talks. Remote hijacking. So you can use, for example, a mobile app, and you use the API of the mobile app, and you modify something in the car, and that actually has an impact on the driver. Hopefully not on the safety, but it's possible. A fun story here. One of my very first drives in 2012 was a Tesla Model S. I came back and I reported that the air conditioning was absolutely going crazy. It goes up and down in the fan speed all the time. And the person driving the car behind me was just smiling and said, "Really? Interesting." So that was the day I learned about the fact that developers have access to all their developer cars through the mobile app, and they were just playing a prank on us. So you have GPS spoofing. Brings us back to the good old days of the introduction of GPS, when people mistaken a ferry for a bridge, right? And they drive into the water. That's the extreme version of that. But basically what you got is you can mislead cars or entire groups of cars into areas where they are not supposed to be. You have the data theft. We talked about that before. Your car is collecting a lot of data, and it's also holding a lot of data. For example, your credit card information or your account information. So this data can actually be extracted and be used for attacks somewhere else. Keyless entry hacking. We all heard about the relay attacks that you can use a simple like suitcase-sized device, and you go next to somebody sitting in a cafe, and you relay the signal over to your partner. He's just opening the door and driving away in your Bentley or something like that. You have malware insertion. So I can actually install something into your car, and I can actually wait for a while until I use that, and then start my attack based through the malware I installed. This is indeed how the Jeep hack in 2015 was performed through malware injection. You have telematics system breach. So I can take data from entire fleets, and I can build data like overviews over certain use areas and so on. In-car infotainment system hacking. So I have the way to get into your display. I can take information out of the display, but I can also produce information or provide information into your display. And over-the-air update exploits. As a matter of fact, we had a hacker in Florida in 2013-14. He continuously did over-the-air update exploits on his Tesla Model S. So what he did is he was sniffing the package from the Wi-Fi, modified it, reverse engineered it, modified it, and then spoofed the mothership communication into his car. And like that, had the ability to modify features in his car. He bought Tesla Model S without the autopilot in 2015 and retrofitted autopilot in both hardware and software with it. with his ability to modify that OTA update. We will obviously we took action in that case, but just to show you the scale of what can be done or could be done. And then yes, denial of service attacks. So if you have the ability to actually ground an entire fleet, suddenly you have the situation not only on one car, but you can have hundreds of thousands or millions of cars somewhere stopping right where they are. So it's a gigantic safety issue. Okay, talking about vehicle to vehicle. So vehicle to vehicle is something that is just emerging, where cars are talking to other cars to share information about traffic, emergency situations, road conditions, and so on. And that I can actually do a remote message injection in two ways. I can actually say the road is much worse than it actually is. So the cars behind me might all slow down. Even worse would be if I tell the road is much better than it actually is, and the cars are going maximum speed at that area and come into an accident situation. I can spoof vehicle identity, so I could probably tell certain systems like public parking areas or payment systems that I'm somebody else and I'm using their identity to pay for my cafe latte. I intercept the data so I can learn what the cars are actually talking about. I can do message relay attacks, so I take the intercepted data, I modify it, and I send it somewhere else. So the car still believes it's a valid information, but it's slightly modified. I can use malware propagation, so I can actually use those channels also to send software or configurations to other cars, which are consumed as trusted. We had the DOS attacks before. And then, yeah, false data injection. As I mentioned before, I can actually create an environmental picture that is not correct to the rest of the cars around me. Now, V2H, vehicle to home. This is getting more interesting. This is something that is really just starting to happen. But if my home and my car are becoming interconnected, I can hack into the car and control my home systems, or the other way around. So I don't actually have to go through the complicated way of hacking my Tesla or my BMW. I can just hack my smart home device that is also on the same Wi-Fi, and I can use the connection between those. I can intercept the data, so not only learning about how the car is used, but also learning how the house and everything around it is used. Unauthorized access to home network, so I can open up the Wi-Fi to any users around. I can insert malware into home devices, so I can update the Google Home or similar things on my smart thermostat by using a vulnerability in the car. I can tamper with energy management systems, and I mentioned earlier we have 41 degrees Celsius here. So if somebody would tamper with my system and turn on my furnace and turn off my air conditioner, I would be fairly disappointed, to say the least. Again, the denial of service attacks, of course. I can spoof home device identities. So I create communications within my home with fake devices. I can compromise the firmware updates similar to the malware injection. And I have unauthorized charging control. Ange just talked about that, so I will not talk about that any further. And I have manipulation of smart home automation. And these days, if you have a very integrated smart home, as I have, for example, my smart home automation is capable of opening doors, opening garages, turn on and off HVAC systems, and so on. So it would be fairly easy to intrude into a home or do things that are malicious to the people in the home once you have ability to manipulate the smart home automation. Vehicle to grid. So for those who are not familiar with that, so vehicle to home and vehicle to grid is different things. So vehicle to home actually only interacts with your home encapsulated system. Vehicle to grid is something we see more and more coming up for energy management, that the vehicles are connected to the power grid, still through your power outlet at home, but it is spanning over the entire power grid, and it's not urgently controlled by you as the homeowner, but usually controlled by your power supply company. So you have, as mentioned before, the remote control charging and discharging. Now it's getting more interesting because not only charging into the car, but you could also basically suck the energy out of the car, and the car, even though it was fairly well charged in the morning, will be empty, the battery. The data interception we talked about. Unauthorized access to the grid network, and following the malware propagation. Tampering with the grid communication protocols. So basically, there's some ways that the energy management companies are controlling smart grid applications in order to cover spikes in energy consumptions. Here in Las Vegas, for example, my smart thermostat is getting controlled sometimes by the energy authority when there's a spike in the afternoon hours, and it reduces the cooling in my home, which I have the right to override it, but in general, it just sends that out through a protocol to all smart controlled thermostats in the whole Las Vegas area in order to reduce the spike in power consumption. DRS attacks, fails data injection into the grid system, so I can actually provide completely wrong information, which has in the end a monetary impact, because if my grid control system pretends that I'm consuming much more energy or I'm not feeding back a lot of energy from my solar system, it actually comes back to me at the end of the month in a monetary fashion. So you have comprised firmware updates, similar to what we talked before. And yeah, you can manipulate the energy pricing and billing. So there are, depending on where you're living, there's very different ways how your energy is priced. So you might have an EV tariff, or you might have like a morning tariff, or you might have like a late night option to charge your batteries, and so on and so on. So this can all be manipulated through that channel. And then you have unauthorized access to energy storage systems. So if you have battery storage into your garage, you want to control when this energy is actually released and in which direction. You don't want somebody to release the energy you actually paid for into the grid, so it will be gone. And vehicle to infrastructure. Now it's getting interesting. So somebody mentioned that earlier, that I think Dan mentioned that the cars know the light color. I think that's still camera based, but it is going to happen more and more. So you have remote control opportunity of traffic lights. Most people don't know how well integrated the traffic infrastructure is already. So I have a friend who runs a business to use traffic light cameras to open corridors for emergency vehicles. And I asked him, how many 100 years you want to wait until you get all those traffic lights equipped? And he said, no, even in your hometown of Las Vegas, 80% of the traffic lights are equipped with cameras and are online. So I was like, wow, I didn't know that, but it's a case. So that being said, if you have the ability to run an attack on a vehicle to infrastructure to a remote traffic signals, we all seen that in the movies, right? So you put all the lights on green and everybody is crashing in the middle of the intersection. Can intercept the data. You have unauthorized access to traffic management systems, because there is some sort of like a mainframe system for every city that controls all the traffic lights, even though sometimes you're sitting in front of an empty intersection with a red light for what it feels like 4 hours, even though it's just 90 seconds. And it feels like there's not much intelligence behind it. But there is compute power behind that. And if you compromise that, you can actually attack the infrastructure of a city. You can insert malware into this infrastructure. Granted, there's fairly limited compute power in those systems, but there's still wireless communication happening. You can tamper with traffic sensor data. So our cities these days actually have a lot of traffic sensors that produce information like traffic jams, like emergency vehicles traveling, and all this kind of things. So by that, you can create quite a fairly big chaos if you're tampering with those sensors. DRS we talked about before. Spoofing of traffic infrastructure devices. So I could actually provide information into that mainframe system that is not real, and I create fake traffic jams, or I remove real traffic jams, for example. We talked about the firmware updates before, and then the false data injection into the traffic systems. So the cars actually provide a lot of information soon into all those systems, not only the status of themselves, but also what they think about the road, what they think about the traffic around, and so on. Honda actually, I read at the conference, is working on a system where the car is automatically reporting potholes. So this is all going through the vehicle to infrastructure systems. And then, as mentioned before, you have the manipulation opportunities for traffic flow and congestion data, which I can imagine is like a fun thing to play around. It's like basically playing SimCity on a real city. So how to handle those threats, and we briefly talked about the ISO 21434 and the UNECE, and I hear that Tyson later is talking about that more in detail, so I'll just sprint through it really quick. But you need to install a cybersecurity management system. as mandatory in the EU, but you should have that installed or in place in every market. You have to create a cybersecurity culture, and this is very important. This is nothing technical, but your companies have to adopt a cybersecurity culture that sets cybersecurity first and reaction times low on that. I'll talk about that on the next slide. You have to run a risk assessment and a risk treatment plan. You have to incorporate that into your development. I heard a lot, it's like, oh, once we have our product ready, we put cybersecurity on top. That's the wrong approach. So cybersecurity has to be at the root of the product development. And you have to have a plan for incident and vulnerability handling in order to actually react on issues when they appear. And cybersecurity, and we heard about that before, I will not go into detail, but needs to be an integral part of testing and validation during the software development and release process. And you have to come up with an approach, and I see the industry struggling heavily. How do you handle your supply chain and your third parties when it comes to cybersecurity? That's a whole presentation in its for itself. So you have to be prepared. What does that mean? You have to be ready to release software at any time with hot fixes. You can't wait 6 weeks, 12 weeks in order to run a software update to your cars while the fleet has to be grounded due to a cybersecurity issue. So what I recommend is to have a backbone software integration approach. So you have to have your software always running. Don't run big bang integration every 6 weeks. That is not going to work for fast reaction times. I'm calling this the 3-branch concept. So you have to have your customers on a branch of software. Your validation team is preparing the next rollout on a separate branch. And then you have a development branch where you actually have to, new things. And that is the most most volatile branch. Again, a whole different presentation by itself. I'm happy to talk about that, but I don't have time for this in this presentation. Very, very important. Keep your customers up to date. 15 years after end of production software updates. Imagine you have to run a software update on a 1999 Buick today. It's absolutely impossible. So the way you have to handle that in the automotive world is you have to keep your customers continuously up to date. As a little secret, Tesla customers are so happy that they get Christmas updates, and it's like, that's so nice of the company. Well, no, that is to bring the whole fleet back on the same branch. And to make it nice for the users, we just put in a couple of like gimmicks. So I will not go into the testing right now. I have a summary here because I'm running short on time. So my statements, 3 statements. First, safety first, obviously, but security first as well. If your product is not secure, it's not safe. It doesn't matter how you test and implement your safety. As soon as it is vulnerable to cybersecurity actions, it will be unsafe eventually. Software updates are not optional. You have to be able to act fast. As soon as your vehicle is connected, you have to be able to also update it through that connection. And last point, remember, your system might be the target, not the vulnerability. So the vulnerability might be somewhere completely different, and you are using a trusted network that has a vulnerable user somewhere in it. And it might actually be also the other way around. So for entertaining purposes, this is my last slide. Please go on LinkedIn, connect with me on LinkedIn. Don't follow me. I am not looking for followers. It's not TikTok. I'm looking for connections. So please connect with me on LinkedIn. What you see there in the middle is Starman, currently somewhere far away from us on the bottom left. And on the top right, that picture is the very same car in my driveway. So that's for entertaining purposes. And that concludes my presentation.